The first step, can I simplify on either side of the equal sign? All right, that's the question. Can I simplify on either side of the equal sign? And how do I know? Well, look for those little keys like, can I use distributive property? Can I combine like terms? Or can I use PEMDAS, right? PEMDAS was something that we used to combine like terms or, to simplify expressions. The next step is to identify the goal. Now, why do I always put the goal in there? Sometimes we're just not sure. And so I have 3 questions I want you to ask yourself to help you to get unstuck. And it has to do with the goal that you're trying to accomplish. And then the last step is undo the operations using PEMDAS in reverse. This is the 3rd step. We're not going to do this 3rd step first, okay? We're going to do it 3rd after we've made sure we've done the first 2 steps. Now, some of you, this 3rd step might look like I've never seen that before, and that's okay. Let's practice it. Let's do our thing, and we'll get through it together, all right? Now, let us see. Why is the goal important? The goal, like I said, is sometimes we get stuck, and that is a common thing across the board. Sometimes when you do steps from one step to the other, you get stuck and you wonder, how do I get unstuck? Well, here are the 3 questions you're going to ask yourself. When you get stuck doing an equation, the first thing you need to ask yourself, what is my goal? All right? I had to breathe. So, what is my goal? Your goal is always, in an equation, is always to get the variable, and a lot of times you'll see it's an x, but it doesn't have to be an x. It could be any letter of the alphabet, but x is just very popular. X on one side of the equal sign by itself and some answer on the other side, all right? That's going to be your goal in an equation. That needs to be very clear. We're talking about equations, not expressions. So in equation, our goal is to get the x on one side of the equal sign all by itself. Perfect. So then the next question is, what is in the way? And what do I mean? A lot of times when you have an equation, you'll have a situation where it looks like this. 2x is equal to 7. And people will say, I don't know what to do. I'm stuck. Well, your goal, once again, is to get the x by itself. What is in the way? Well, whatever's on the same side as the x is in the way, right? So that's going to be the 2. That 2 is in the way. So I need to get rid of the 2. If you're thinking I need to get rid of the 7, no, well, the 7 is not on the same side of the equal sign as the x is. So the 7 doesn't matter right now. What does matter is the 2, because the 2 is preventing me from getting to my goal. Okay, cool. I can figure that out. All right, got the 2. What do I do with it? Well, the question is, how do I undo the operation I see? Well, whenever, and this is something we said in another session, whenever we see a number that's attached to a variable, the way this is, like there's no operation between them, written between them specifically. So the assumed operation is multiplication. So I'm multiplying 2 by x. So how do I undo a multiplication by 2? Well, if I'm undoing it or reversing it, I need to divide by 2. Okay, so these are just 3 questions you can ask yourself just to get unstuck. Now, what these 3 questions will not necessarily do is take you directly to the answer, but it will just help your brain to start working to say, oh, okay, I got it from here. Like, I'm good. Thanks, I got it, So just to get you unstuck, and some of you, that's what you need. You just need to get unstuck from where you are and get your brain kind of ticking in the right direction, and you can take it from there to the answer, and that's really good. Some of us need a little bit more help, and that's okay. That's why we're going to spend some time practicing so you can see where we're going. And then lastly, PEMDAS in reverse? I've never heard that before. Well, you've heard of PEMDAS, some of you not, but let me explain what's happening. Once we get to this 3rd step, when we're dealing with equations, once we've simplified everything and we figure out what our goal is, when we're dealing with equations, the thing about equations is that we're trying to figure out the piece of the puzzle that's missing. Just like earlier when we had the equation 20 equals x plus 15, we know the answer was supposed to be 20, but the x is the missing piece of the puzzle. What does that x need to be so that when I add it to 15, I get 20 as my answer? Well, in order to figure out the missing piece of the puzzle when it comes to equations, we move back in reverse. We undo everything we did so that we can figure out what's the missing piece of the puzzle, all right? And so this is where we introduce the concept of doing PEMDAS in reverse. So, PEMDAS, the P is for parentheses or groups, and pretty much anything in a group. The E is for exponents. The M is for multiplication, D division. A, addition, S, subtraction. So we're going to tackle those. We do PEMDAS when we're simplifying expressions individually, just like in the first step when we're looking at individual sides of our equation. But then when we're looking at the entire equation and trying to get the x by itself, then we're going to do PEMDAS in reverse. So we're going to practice that. I said it. Now let's practice it, okay? All right, here we go. What is our goal? So let's do all of our steps, okay? So our first step is, can I simplify? Can I simplify on either side of the equal sign? So for now, I'm going to pretend like my equal sign is a wall. I'm just writing here for just teaching purposes. You do not have to draw a wall on your book. But imagine it's a wall, and I'm just going to consider one side at a time. And this is where I'm going to simplify. So looking at the left-hand side, where it says x plus 5, can I simplify? In other words, can I combine like terms? No. The x and the 15 are not like terms, okay? And why is that the case? Well, the x is a variable of x, and the 15 does not have a variable of x, so they're not like terms. I can't use distributive property. There are no parentheses. There's no multiplication happening. That actually can happen, so I'm done with that. And there's no way I can use PEMDAS at this point. So on the left-hand side, there's no simplifying. Like, I'm done. I don't have to simplify. So perfect. Now let's look at the right-hand side. The right-hand side is 20. Just 20, in your face kind of 20, okay? And it just so happens that there's nothing that I can do with that either. All right, so my step 1 is done. Isn't that cool? We just finished step 1. We didn't have to do anything except for just compare and see what we had with us, all right? The next step is to identify our goal. Our goal is to get to the x. All right, now remember those 3 questions that we asked to get unstuck? Okay, we know what our goal is. What's in the way? What's preventing us from getting the x on that side all by itself? Well, what's in the way is this 15, specifically a plus 15 or a positive 15, plus 15, right? Now, if your thought was, oh, the 20, I need to get rid of the 20, well, notice the 20 is on the opposite side of the equal sign. So if it's on the opposite side, it's not in my way. It's not doing anything to me. I can leave the 20 alone. Let's move everything away from the x. Now, so I have a plus 15. So the next question, a part of that unstuck slide, was how can I undo the operation that I see? Well, how do I undo an addition of $15? In other words, if I gave you $15, that's like plus 15. How do I undo that? How do I reverse that? I reverse it by subtracting or taking it away from you. So I'm going to subtract 15. All right, think about that for a second. And then I want you to think about that example we talked about earlier with someone giving you and your arch enemy money, a $20 bill. Well, if I went ahead and took $15 from you, you would say, wait a minute, if we're equal, you have to take $15 from this brother over here too. Otherwise, it's not equal. So equations, the rule of equality applies. So if I take 15 from the left-hand side, I must also take 15 from the right-hand side as well. All right? Whatever I do, even if I didn't do it right, whatever I do on the left side, I must do on the right side. All right? So here we go. What does my next line look like? Well, the x, I did not do anything with the x, so I'm going to go ahead and just bring that thing down to the next line. Now, a plus 15 or a positive 15 minus 15 will give me a 0. All right? So that's gone, which was my goal. My goal was to get rid of it or to undo it. So x is equal to, what's 20 minus 15? Well, that's going to give us a 5. All right? So what does that mean? That means that x is equal to 5. All right, now if you wanted to check your answer, what you'll do is you'll take a look at the original question, which is x plus 15 is equal to 20. And what you need to do is, where you see an x, you're going to substitute that for 5. So it'll be 5 plus 15 is equal to 20. And is that correct? Yes, it is. And that's how you would check your answer if you wanted to check your answer. All right, so that's how we would do the 3 steps. Now the question is, well, I didn't do PEMDAS in reverse. Well, notice that we only had one operation. In other words, we just had addition. So PEMDAS in reverse is really good when we're dealing with multiple operations. But notice we were able to get rid of get to our answer without even getting to the 3rd step, which is really cool, right? All right, let's keep going. Now we had addition. What happens when I'm subtracting something from x? Okay, let's take a look. Same process. Ignore the equal sign, or pretend like this is a wall for a second. I wouldn't say ignore it, but just pretend like it's a wall. And let's see, can we simplify on either side of our equal sign first? Can I do that? Well, if I look at the left-hand side, I have x minus 5. Now, if I'm subtracting terms, there's only one operation, so I have to subtract. If I'm subtracting terms, they have to be alike. Are they alike? Well, the answer is no, they're not alike. Why? Well, because this is a variable of x, and this is just a constant. So they're not going to be alike. The 5 would need to have the same variable for it to even be considered as like terms. So that's not the case. So they're not alike. So I can't simplify there. And then 20 is just 20, in your face kind of 20. So, you're done with that. You don't have to worry about it. So now that I finished my first step, identify my goal. My goal is to get this x. All right, now that those 3 questions about being unstuck, I know what my goal is. The question is, what is in the way? What's preventing me from getting to my goal? Well, what's preventing me is the minus 5. Another way you can think about it is negative 5. It's okay, same. All right. So how do I undo a subtraction of 5? How do I reverse that? Well, the opposite of subtracting 5 is adding 5. Okay, so I'm going to add 5 to itself, so plus 5. And once again, the rule of equality applies. Whatever I do for you, I have to do for someone else. That's what equality looks like. So plus 5. All right, there we go. Now let's do the math. Let's do the math. So x comes down. Now this applies to any situation. Whenever you do not tackle a term or do anything with a term, you can just bring it back down. You can literally just rewrite it because you haven't touched it yet. So the x comes down. Negative 5 plus 5 is going to give me a 0. And then 20 plus 5 is 25. And so here we go. X is equal to 25 is my answer. Awesome. So we're able to get through this using the first 2 steps. Haven't gone to the 3rd step yet, but we will, right? Because these are simpler equations. These are literally just 1-step equations. Let's take a look at another example. Ooh, this looks a little different than the last one. What's different? What would you say is different about this one? Well, what's different is you have the number out front and the x follows after that, right? Some people do get confused when the x is in a different position. But let's tackle this for a second and take a look at what we have, all right? First of all, step 1, simplifying. Can I simplify? Can I simplify? Once again, we're going to pretend like this is a little wall. And the reason I'm saying it's a wall is because I want you to notice that I'm only talking about the left-hand side of that wall. Not both, just one side at a time. So on the left-hand side of this wall, I have negative 5 plus x. All right, can they be simplified? Well, what they're asking me to do on the left-hand side is to add them. Well, in order to add 2 terms, they have to be like terms to do that, and they are not. All right. Now, if you haven't caught on to why they're not as yet, you can go back and watch our 2nd session, and we'll talk about. And it talks about like terms at that point. And now let's take a look at the right-hand side. On the right-hand side, we just have 20. Once again, in your face kind of 20, and you can't do anything with that, guys. So we're done with the first step. Our 2nd step is, what is our goal? Well, here's our goal. Our goal is to get to the x. We want to get to the variable. And once again, that x is just a letter. It can be any letter in the alphabet. It does not matter. So what is in the way? What is in the way? Well, what's preventing me from getting to my goal? I need to consider everything that's on the same side as the x, on the same side of the equal sign. And I have a negative 5 sitting here. Okay, no problem. Well, what I want you to keep in mind is whenever you have a negative number out front, or even a positive number, it doesn't really matter, but it's the same as saying 0 minus 5, or if it was positive, 0 plus 5, or whatever the number or term is, same thing. So why am I saying that? Well, because our next piece when it talks about getting unstuck is, how do I undo the operation I see? Well, I see a minus 5 or negative 5. So I'm going to undo that by adding 5. All right, now the 0, you don't have to worry about it. I just put it there so you can notice that it's like I'm just adding 0. I just have a 0 in front, okay? Some people say change side, change sign. If that works for you, work it, No love lost in that regard. All right, so let's go ahead and do the math. -5 plus 5 is going to be 0. All right, the x, I haven't touched it yet, so that stays there. And then 20 plus 5 is 25. All right, good. So my final answer is 25. All right, so you can look back at that again. Let's look at another example. So we talked about addition, we talked about subtraction, and then what happens if the terms change position, right? This is a good example of that. But what happens when I have this? What do I do? You can pause here. You can try it on your own and then keep going, all right? What do we do? Let's go through the steps. Same 3 steps every time. Can I simplify? Well, if I take a look at the right-hand side and the left-hand side individually, as if this is a little wall right here, 20 is just 20, in your face kind of 20. And then 2x is just 2x. 2 times x, you did, that's it. It is what it is. No way to simplify that any further. So now our second step is our goal. Our goal is to get to the x, all right? So those 3 questions to get unstuck. You know what your goal is. What's in the way? Well, the 20 is not on the same side of the equal sign as the x is, so the 20 can't be in my way, but there is a 2 that's sitting here, all right? Perfect. Now the question is, how do I undo that? Well, here is where sometimes students might get confused. They might say, oh, I see a positive 2, I'm going to subtract 2. And that's not what's happening. What operation do you see? Look at it very carefully. When you have a number, which is going to be a coefficient in this case, that's attached to a variable, and there's no explicit operation given. Like, for example, you don't see a minus sign between them. You don't see an addition sign between them. You also don't see division. Then the assumed operation is multiplication. So MUL, I'm just going to put MULTI. That's my shortcut to multiply, okay? So if the operation is multiplication, how do I undo that? What's the opposite of multiplication? Well, division is the opposite of multiplication. And what am I dividing by? I am dividing by the thing that I'm multiplying by, which is the 2. Now keep in mind, you're not multiplying or dividing by 2x, because you're not trying to move the x. You're trying to move the 2, because that's the problem. You're trying to get rid of the problem. The x is not the problem right now. So you're only dividing by whatever is being multiplied by the x, all right? And whatever I do on one side, I have to do on the other side. Whatever I do for you, I have to do for someone else if they are equal, if you're both equal. So here we go. 2 divided by 2 is 1. So I end up with 1x, or just x. And then 20 divided by 2 is 10. There you go. And you can check your answer the same way we checked our answers previously. The original question says 2x is equal to 20. And we already established that the operation there is multiplication. So what this means is 2 times x, which in our answer is 10, is that equal to 20? Well, the answer is yes, it is. So that's a way to check your answer, all right? Now we did addition, subtraction, we're doing multiplication by a positive number. What happens when it's negative? Same concept, right? Can I simplify? You do that answer. You probably can look and say, okay, I can't simplify. I can see I can't simplify by now. So I can't simplify. Now, what's my goal? I want to get to the x. All right. So the 3 questions, how do I get unstuck? I know what my goal is. What's in the way of that happening? Well, I have a -2 sitting here. All right. Now the question is, how do I undo the operations that I see? Well, this is also where sometimes it can be confusing, because you might see a negative sign and say, oh, I can just add 2. Now, this is where I'm going to tell you to pause, hold your horses, okay? Is the subtraction sign between the 2 and the x? Well, no, it's not. It's in the front of the 2. So what that really means is that I'm multiplying a -2 by an x. So how do I undo a multiplication of -2? Well, I divide. Now, keep in mind, I'm only changing the operation, not the sign. I'm changing the operation. So instead of multiplication, it becomes division by whatever it is that's being multiplied by the x. All right? So the sign does not change. When we're talking about multiplication division, what we're talking about is the changing of the operation. And I just want to say this. When I say operation, I'm talking about that PEMDAS situation. All right? Whatever the opposite is addition, the opposite of addition is subtraction. The opposite of multiplication is division, and so forth, all right? And then once again, whatever I do for you, I must do for others. So I must go ahead and divide by 2 on the negative 2 on the right-hand side as well. All right, so let's do the math. Negative 2 divided by negative 2, so I'm dividing by 2 negatives. That's going to give me a positive answer. So that's going to be x, positive x, or positive 1x if you want to put that in there. And then a positive 20 divided by a negative 2 will give me a negative 10. All right, and you are welcome to check your answer as well. Now we did addition, subtraction, multiplication. Now let's take a look at division, all right? Does this work in division? Yes, it does. You can try it on your own if you would like to. So here we go. Can we simplify on either side? The answer is no. And one of the reasons, we just have 20 over here. 20 is 20. And then x divided by 2. Well, there are no, if we had the same variable in both the numerator and denominator, then we can simplify a little bit. But in this case, I don't have a variable in my denominator. I just have a constant down there. So I can't simplify. So next thing is, what is my goal? Well, I need to get to this x right here. Now notice the x is in the numerator. Okay. So what's in the way? Well, I have a division here. I have a 2 that's there, and the operation that's happening is I'm dividing by 2. Another way to look at this is as if I'm multiplying by a half. Excuse me. But right now we're just going to look at it for what it is. I'm dividing by 2. And how do I undo a division by 2? Well, I need to multiply by 2. Okay, now notice that 2 goes into the numerator, all right, multiplying by 2. And I must do the same thing on the left-hand side. So 2 times 20 is 40, and that is equal to, on the right-hand side, notice the 2 in the numerator cancels with the 2 in the denominator, and I'm left with x. All right, now the question is, am I done? Have I met my goal? The x is on the other side. What do I do? Well, the question is, have I gotten the x on one side of the equal sign all by itself? And if the answer is yes, then you're done. It doesn't matter which way they appear. So 40 equals x is the same as saying x is equal to 40. All right, there you go.